Hello. I received a lot of questions regarding the last homework question in homework one, using the pycnometer in order to find the density of a solid. And so I thought I would go through that question with you. I really like this question a lot. The reason I like this question is it really starts to illustrate the level of different thinking, and the level of thinking in general, and the level of problem solving ability that you're going to need in order to be successful in a class like this. There was no new science in this question. There was no new chemistry. The only chemistry involved, the only science involved was calculating density, which is something that we had done a bit of in this unit in general, just taking our mass divided by our volume and finding a density. The difference is, in this question, you weren't simply given the information. You weren't simply told what the mass is, told what the volume is, and asked to divide them. Or it wasn't a matter of simply maybe doing a couple little conversions and then getting things into the proper units and dividing it through. You had to really think about what's going on here. And you had to think about the information that's given and how you were going to use that information in order to find these two terms. So using the information given to find the mass of the metal sample and to find the volume of the metal sample. So how were you going to use all the information you had in order to find those? And so let's first take a look, as we're taking a peek at this, let's take a look at what a pycnometer actually is. So a pycnometer is just this glass flask with a tight stopper here and an opening for liquids or gases to escape. In this case, it's going to be liquids. And so if we follow through with what's happening here, so it says that a pycnometer can be used to determine the density of an insoluble solid by measuring the volume of water ejected when the sample of the solid is placed into it. And so what we have going on is this pycnometer then is filled with water. So we fill this up with water. And then when it's filled up with water, we're going to take our insoluble solid and we're going to put that inside. We're going to drop that solid inside. And so what's going to happen then? The pycnometer is full. Think about what happens if you completely fill a bathtub and then you climb in. What's going to happen? Water is going to slosh out over the top, right? The volume of U is going to displace some of the water in the tub, and so it's going to spill over the top. Same thing will happen here. We have our full pycnometer. We're going to place our solid into it, and when we do that, water is going to be ejected out the top of our pycnometer here. If I can just drag that image back down, maybe I can. Okay. And so the volume of that water that's ejected is going to equal the volume of the solid that we put in there. And so we're going to be able to use that information. And so let's start to now think about the actual information that we're given. We are given, for one thing, we're given the mass of the clean pycnometer. So we're given the mass of this thing just as it exists by itself. And so the mass of our pycnometer, the mass of this by itself equals 25.151 grams. And so remember that that's just the pycnometer just by itself. We're also given the mass of the pycnometer plus the metal. So once we if we drop our metal sample here in the bottom without any water in it, now it's just the pycnometer plus the metal. So the mass of this whole thing, the mass of the two of these together, so the mass of the metal plus the pycnometer, we are given as 39.105. Now you were probably given a different number here. One of the things that Chem 101 will do is, for some problems, people get different numbers to work with. 39.105 is the example that I have in this case. Your problem probably had a different number there, but it's the same exact process that we're going to walk through. And so we have now our mass of the metal plus the pycnometer. We have the mass of just the pycnometer. And so what do we do to find just the mass of the metal? We subtract. So we have our 39.105 grams. It's the mass of the two of them combined. Sorry. Minus 25.151 grams for a mass of the metal sample of 13.954 grams. And so if we come back to our density formula, we now have this density, or sorry, we have this mass, 13.954 grams. We still need to find the volume of our metal. So that's the last thing that we need, and that is going to be a little bit more complicated. But again, we just have to think about the information that we're given. And so we need the volume of the metal. And remember what I said is that volume of the metal is going to be equal to the volume of water that's ejected. So the volume of this water that's ejected is going to be equal to the volume of our metal. So we need to find the volume of that water ejected. We're not given any data that has anything to do with volume. We are, however, given a lot of mass information, and we're reminded that the density of water equals 1 gram per cm cubed. That means that if we can find the mass of this water that's ejected here, then we can use the density to equate that to the volume of the water ejected. So that tells us that we need to find the mass of this ejected water. And so again, let's start to take a look at all the information that we're given. We are given, once again, we know the mass of the empty pycnometer. So that mass of the empty pycnometer was equal to our 25.151 grams. We're also given the mass of the pycnometer plus the water in there. So the mass of the pycnometer plus water equals this 42.481 grams. And so now we can subtract the two of those. 42.481 grams minus 25.151 grams. We do that subtraction, we have a mass of 17.330 grams. And so that is equal to the mass of the water initially present. So before anything is ejected out, before we've done anything, we just have our water sitting in our pycnometer. The mass of that water sitting in there is 17.330 grams. We also know we're given some final information here, what the mass is of the pycnometer plus the metal plus the water that is left over after some is ejected. And so let's just sort of take a peek at that. So remember what's going on here is we have our pycnometer with water in there. We drop our metal sample in. We drop that metal sample in. Some water is ejected. And this 54.265 that we're given here, that is what is left just down here now. So that's 54.265 grams. That is our pycnometer plus our metal plus the water that was left over. if we subtract that now from the mass of the empty pycnometer that we had before, so from our 25.151 grams, that leaves us with a mass. Sorry, let me back up. I was looking at the wrong thing. What we want to do now is we want to find the mass of just the water that was left over in here. So the mass of the water left. Because if we subtract the mass of the water that we initially had present, so remember we found that here, we found out how much water was initially present in our pycnometer, our 17.330 grams. If we're able to find the mass of the water that's left and subtract that from the mass of the water initially present, that's going to give us the mass of the water that was ejected. And so we can take our 54.265, that's our pycnometer plus our metal plus our water. We're going to take that number and subtract the pycnometer plus the metal. Remember, the pycnometer plus the metal was our 39.105. So we subtract those and we get a mass of 15.160 grams. And so remember, that's the mass of the water we have left over, 15.160 grams. And so finally then, what we're going to do with that information is we're going to take the 17, sorry, I'll come back, our 17.330, that was the mass of our water initially present. And so initially, we had 17.330 grams of water. That's how much water was just initially in our pycnometer. And now we can subtract the mass of the water that was left. So the mass of the water that was left in there was our 15.160 grams. Remember, that's what we found right here. So 15.160 grams is the amount of water left after some of it is ejected. And so we subtract those two numbers from each other, and we get a value of 2.170 grams. And so remember, that equals the mass of the water that was actually ejected. That equals this mass right here. Okay, now we're getting somewhere. So that's the mass of water that was ejected after we dropped our solid in there. And so remember, we'll come back now to our first slide here. What we're looking for is the volume of that metal. Well, what we know now, at least, is the mass of water ejected now is equal to 2.170 grams. That means that the volume of water ejected, since the density of water is 1.000 grams per centimeter cubed, that means the volume of water ejected is 2.170 cms cubed. And remember, the volume of water ejected equals the volume of our metal sample. So now, that number can go right in here. And so instead of just the volume of the metal, we know what that number actually is. So we'll erase that, and we're going to put in 2.170 cms cubed. And we do the math, and we find an answer of 6.430 grams per cms cubed for our density. Let's see if that agrees with the answer here in Chem 101 for the numbers that I was given. Sure enough, 6.430. And here we can see their solution. I'll blow this up so you can pause the video if you want and read through their solution here. Same exact thing that I just went through. It's just that some of the values are going to be different. First, they calculate the mass of the metal sample by subtracting the pycnometer from the pycnometer plus the metal. There's our 13.954. There's our mass of the metal. And then they walk through the same basic process that I did, finding the different volumes and the different masses and the mass of the water ejected to eventually get to our 6.430. And so again, your number from your problem is going to be a little bit different because you were given different amounts for your, what was it? I think for the mass of the, it was this one here, if I remember right. It's not grayed out anymore, so I don't see it. Yeah, the clean pycnometer plus the metal. So you had a different number right here. So you'll find a different density, but it's the same exact process. Now again, remember, like I said, there's no new calculation here. The heart of this whole calculation is right here to get to our final answer. It's just a density calculation. The difficulty in this problem laid in the digging through the information to see what's really going on. And so it required you to really dive in and think about it. There was a student on Piazza who compared this to an accounting question, and I really liked that analogy. That's really what it is. It's looking at all the different masses and all the different information that you're given and seeing what you have to subtract and what you have to compare what to what in order to find the masses that you're ultimately looking for. And that's a great way to think about it. And so go back. If you didn't get this problem correct before, you should be able to go back into Chem 101. You can't resubmit an answer, but you should be able to see the solution and to see the question that you had. Go back through it. See if you can apply this same problem-solving technique and see if you can come up with the same answer that they do. And really what I want you to do, though, is make sure that it makes sense. Make sure that this problem-solving approach, that this level of thinking that we have to do in a problem like this really makes sense to you. Because you are going to have to be able to think deeply like this in order to master a lot of the content and master a lot of the calculations and things that we will see this semester. And so I really hope this was helpful. If you have any questions about it, as always, feel free to send me an email and we'll see if we can help you out. In the meantime, I hope this helped out and I will see you later. Thanks for watching.